I want to show you an interesting property of pennies. I have a collection of pennies here, and I'm going to mass them on this scale. So I'll put a penny on there that's about 2.5 grams. And I'm going to put another penny on there. It's at 2.5 grams. Put another penny on there. 2.5 grams. So you might get the idea that all pennies are about 2.5 grams. And that one's a little light. I think there's a problem with a tear here. Try that again. Okay, 2.5 grams. And let's try this one. Whoa, that went up to 3.1 grams. Maybe that's just a freak penny. Let's measure another one. 3.0 grams, another freak penny. Put another one on there. 3.2 grams, another freak penny. Oh, now we're back to 2.5 grams. The point being that there's actually two different masses for pennies. 2.5 grams or about 3.1 grams, depending on what type of penny it is. Older pennies were made out of pure copper, which is a little bit more dense than the more modern penny, which is made of zinc with a copper jacket. They did that in order to reduce the cost of making pennies by making most of the pennies zinc and only a little copper coating on the outside. Now you can see how this might induce an error in our spaghetti lab experiment. And I want you to think about whether you think this type of error would be a random error or a systematic error in our experiment. Here's a little interesting little problem you can do, a little algebra problem. I'm going to zero the balance with this cup on there. And I'm going to take 25 pennies and I'm going to put them in the cup. After I've carried the weight of the cup out. So I'm just measuring the mass of the pennies. And when I put all these pennies in there, I get a total mass of 67 grams or so. Now if I have in fact 25 pennies in there and the total mass is 67 grams, using a little bit of algebra, you should be able to figure out how many pennies of each type are in that cup, given the fact that the heavier penny is 3.1 grams and the lighter penny is about 2.5 grams. So I'll let you figure that out as an algebra problem. That's kind of tied into chemistry and the concept of atomic weights. A proton has an atomic mass of 1. A neutron has an atomic mass of 1. An electron is basically 0. So the question is, how can you have an atom that has an atomic mass that's not an integer, if it's just made up of protons and neutrons essentially, and each of those have a mass of 1? And the reason is that when you look at the mass of some element and it has a decimal value that isn't an integer, you're really looking at an average of all the different isotopes of that element. Much like you're looking at the aggregate of two different kinds of pennies here, we could take that number and divide it by 25 to figure out sort of the average mass of a penny, and it would be neither 2.1 nor or 3.1 or 2.5. There'd be some value in between. And likewise, when you're looking at the periodic table and looking at atomic masses, the atomic masses are never integer values, because you're really looking at an average of all the different isotopes of that element, and different isotopes have different numbers of neutrons, and therefore they have different masses. Although the element depends on the number of the element just depends on the number of protons, which doesn't vary within a given element.